Hey, this is Mr. Weisefeld. I thought we would talk about the green sheet. This is also known as the quiz, the PS1B quiz for Newton's second law from Activity 2 in Chapter 1. So on this side, all you really have to do is just put your name and the period. So what period is this? This is like 0. I'm not even in a period right now. And a little bit about Sir Isaac Newton. You can read. A summary of Newton's laws. Remember that that this right here, Newton's first law, this right here, Newton's second law, and we're going to cover this one pretty soon, Newton's third law, just if you want to review some of those. Then if you take a look further down the page, you've got a little bit of a summary of inertia. One of the keys is if you have more mass, you have more inertia. And then a force, we pulled on things a lot, but we also need to make sure that a force can be a push as well as a pull. Either one of those, if it causes motion or changes motion, it's a force. Net force, when you want to find out what the leftover force is on an object, this is kind of a crazy drawing with tractors and things, but if you want to draw just a little box and say that there's 400 newtons to the left and 200 newtons to the right, a little bit smaller arrow, right? Then I think you can see that the resultant force, the net force, is going to be 200 newtons to the left. You would subtract those two, and then the resultant force is in the direction of the larger force. And technically, you don't need the negative sign if you're going to put on the left part. So you could just say the net force of this box on this box is 200 newtons to the left. And this is what I need when you tell me a net force. Since force is a vector, I really need to see the following. I need to see the amount, the unit, and the direction. So we say I need the magnitude, I need the units, and I need the direction. In most cases, that'll get you 3 points out of 3. If you forget one of those, then I take off a point. So please try and keep those all together. All right, here's Newton's second law written out in mathematics in a formula. You've got force equals mass times acceleration. You can write it out in words. You can also say that newtons is kilograms times meter per second squared. If you wanted to tease out some of what that's saying, if you have more mass, you need more force. And if you have more acceleration, you need more force. So notice that when I stomp on the gas, I'm using up more energy. When I stomp on the gas pedal, I have to accelerate more quickly. That's adding more force. That's wearing out your engine, etc. But mostly it's using up fuel economy. It's using up your fuel less efficiently. Hey, these questions at the bottom, these are samples. So when you want to know what the force is, if you're given a mass and you're given an acceleration, then just multiply them. Force equals mass times acceleration, right? If you're given a force and the kilograms, then use the cheat sheet circle, right? So if you've got force equals mass times acceleration, but I give you a mass, then what's left over is acceleration F over A. So you can see here, dang it, this one they're asking about what is the acceleration. So if I have force equals mass times acceleration, I want to know the acceleration. I cross that out. It's force divided by mass. Force over m, F over m. So you can see them dividing F over m to get A. A is in meters per second squared, and if there's a direction, I need a direction too. In this case, there isn't, so you're okay. When you don't need to give me direction, you get 2 out of 2. Now, this is the one I was just doing. If I have newtons causing an acceleration, so a force, what is the mass? Use your cheat sheet again. F equals m times A. In this case, I need my mass. Cross it out. It's F over A is the equation. And mass is in kilograms. So don't forget the units of kilograms. And you don't need a direction for mass. All right, so the tops of these pages were mostly the same. I've made another version of the sheet where I've changed some of the stuff up, but forces are measured in newtons. So this is 6 newtons. M is mass, and so that's measured in kilograms. So I've got newtons and I've got kilograms. Acceleration is measured in, so this is acceleration, I'll call it. It's measured in meters per second squared, so 3 meters per second squared. V is velocity, or speed. It's measured in 29 meters per second. M per s, you could say. D is distance. This was a little confusing, I apologize, but 228 meters. And then P is called momentum. I was mentioning this to a couple people. Momentum is mass times velocity. So this is mass, kilograms times meters per second. And this is an unfortunate typo here, but it's 23, that there wasn't a space there. Kilograms times meters divided by second. Okay, so get that section down. It's basically what are the units that we use for various things. Inertia, matching, is the ability of an object to resist a change in motion. It's also known as mass. If I have a big tanker or semi-truck on the road, it's going to take a lot of force to slow it down or speed it up. That is what we call inertia. Mass is the total amount of matter in an object, so like kilograms. So mass is the amount of matter in an object. Gravity, so people wanted to say D or B or A, but gravity is actually a force pulling all objects toward each other. In other words, every mass attracts every other mass. And so this is B. The net force is an action that can cause motion. That's true. I guess I could give credit for that, doggone it. But the point is, the net force, the better answer is that the total of all the forces on an object is the net force. And that leaves that the force is A. So that was the matching exercise. Then you have, actually let's do these over here. Newton's first law, second law, or third law. So the answers are either 1, 2, or 3. When I put a book on the table and the table pushes back up on the book, that means that the weight of the book is pressing on the table and the table is pressing back on the book. That's Newton's third law. That's action equals reaction. A person is pushed forward in their seatbelt, so the person wants to keep moving even though the car is stopping. The only way the car knows how to stop a person is with the seatbelt. Otherwise, in accidents, you fly through the windshield without your seatbelt. Please wear your seatbelt. The point is, that's all Newton's first law. That's all about inertia. You have a resistance to a change in motion. The car slowing down is changing your motion, and you will resist that. A larger car takes more force to move. That's Newton's second law, F equals ma. What we did is we said if m is bigger, then a is bigger. A person is leaning on a wall. That means I'm kind of putting a force on a wall. The wall pushes back on me. That's action-reaction. That is Newton's third law. And now a brick is sitting on a table until I push it. Now, okay, I know the brick is being held up by the table, so that would be Newton's third law, action is reaction. But this is talking about I'm almost pushing the brick. As soon as I push the brick, it's going to keep motion, but it's sitting still until then, so it's Newton's first law, law of inertia. I think virtually everybody is getting these right here. The object is going to move to the left, and the net force is 5 newtons to the left. So that's why it's moving to the left, is because you have a net force to the right. This one, similarly, you're moving to the right, and you've got 2 newtons to the right. And then, if the forces are balanced, so notice this is equal to this, that means the net force is 0. Net force equals 0. That means you are not accelerating. And please don't miss this. This does not mean you're not moving. I mean, you could be moving with balanced forces. You're just not speeding up or not slowing down. So it's not accelerating. That's what we call not speeding up or not slowing down. So that was net forces. Now, you have the least inertia and the most inertia. And so one of the ways to think about this is what has the least mass and the most mass. So if I look at these, seems pretty clear that a train has the most mass, a large train especially. And I'm thinking about a choo-choo train. Feather has the least mass. A baseball has more mass than a feather, but less mass than a small car or a truck. A truck has more mass than a small car. So it goes like this. 2, 3, 4, 1, 5. Looking at inertia. Now, momentum. So if momentum, that's P, equals the mass times the velocity. This was above and beyond question. If my mass is big and my velocity is big, then my momentum is going to be largest. So a fast car has the largest mass of any of these, and it also has the largest speed. So this one's going to be the most momentum. A parked truck, velocity is 0, that has the least momentum. Even though it's a big object, mass is large, it's not moving. So that's the least. A slow car, I'm going to say, has a little bit less momentum than a fast car because it also has a big mass. It definitely has more mass than a baseball or a feather. A feather only has slightly more momentum than a parked truck, only because it's moving. Not because it's huge, but just because it's moving. And then a fast baseball has a little bit more mass than a feather, definitely more speed than the feather. Well, no, it has comparable speed to the feather, but it hasn't got the mass of a slow car. So, hey, you could argue that these should be switched, 4 and 3. If you feel like you have been wronged in this question, tell me what the mass and velocity of a car would have to be so that it would have less momentum than a fast baseball. In other words, find the mass and the speed of a baseball, a fast baseball, and tell me, and I'll make that offer to anybody. If you want to argue these, then tell me what the masses and velocities are, and then we'll calculate it, and you could have the right answer. So now let's do these questions at the bottom here. So first off, a sled is being pulled to the left by 5 dogs. Here's my sled. I've got 6 newtons from the first dog, 6 newtons from the second dog, 6 newtons from the third dog, 6 newtons from the fourth dog. Do you get this pattern here? 5 dogs pulling at 6 newtons each. Let me put in the newtons here. 6 newtons, 6 newtons, 6 newtons, 6 newtons, right? That's just 6 newtons times 5 dogs equals 30 newtons total force to the left. To the left. So this is how you get full credit. You got the answer, you got the number, you've got the units, newtons, and then you've got the direction to the left. Some people draw arrows too, that's good. All of those get you 3 points out of 3. A 20 kilogram bike, so you think to yourself, what's kilograms? Is it a force? Is it a mass? Is it an acceleration? Accelerates at 10 meters per second squared. Is it a force? Is it a mass? Is it an acceleration? Kilograms is mass. Meters per second squared is an acceleration. Force equals mass times acceleration. What have I got? What have I need? What have I got? What do I need? 20 kilograms times acceleration 10 meters per second squared. Oopsie. Let me fix this here. 20 kilograms times 10 meters per second squared equals 200. And the units? Newtons. Do I need a direction? No, I don't really know which direction this is. But I have 2 points out of 2 because I have the right number and the right newtons. And the right units. A person pulls on a cart to the right with the force of 10 newtons. And a second person pulls to the left on a cart with 3 newtons. What is the net force on the cart? Well, which way is this cart going to go? It's going to go to the right because this is bigger. How much bigger is it? 4, 5, 6, 7, 8, 9, 10. 7 newtons to the right, to the right, to the right. That's 3 points out of 3. I've got the size of the force, I've got the direction of the force, and I have the units of the force. Alright, next question. I'm pushing on a cart with a force of 40 newtons. Is that a force, a mass, or an acceleration? That's a force. And it accelerates at 0.5 meters per second squared. Is that a F, an M, or an A? Is that a force, a mass, or an acceleration? That's an acceleration. So I use my cheat sheet. F equals M times A. The question is asking about the mass of the cart. So I cross out mass. What do I have left? I have force over acceleration. F over A is 40 newtons. So I said that was the force right there. Divided by 0.5 meters per second squared. That's going to be 80 units for mass. Kilograms. Don't need a direction for kilograms. Plus 2 out of 2. Alright. I hope that I might be convincing you here through these examples to draw these little pictures. So I've got a 0.5 kilogram object, 2 newtons and 6 newtons pulled to the right, 2 newtons, 6 newtons, and 4 newtons pulled to the left. What's the net force on the object? Which way is this object going to go? Well, it looks like I have 8 on one side and 4 on the other, so it's going to go this way. And it looks like if I have 6 plus 2 minus 4, I have 4 newtons net force to the right. Now, I added part of this question. I also had you find the acceleration. So the acceleration, F over F equals M times A. And so if I want to know the acceleration, it's F over M. So that's 4 newtons to the right divided by 0.5 kilograms. That equals 8 units for acceleration. Meters per second squared. And that's to the right. Acceleration is a vector, so you need the direction on an acceleration, especially in a problem where we're giving you directions. So that's 3 out of 3. This worksheet is credit C. Stephen Murray, copyright 2004. Check out his website. He's got more of them. Thank you, Stephen. It's a great work you've got here. What is the acceleration? So F over m times a, or force equals mass times acceleration. I want to know acceleration. It looks like I need a force divided by a mass. So one of these is a force. Which one? Newtons is a mass. So 18 newtons divided by 3 kilograms equals acceleration. That's 6. The units for acceleration? Meters per second squared. Don't need a direction because I don't know really which direction this is in this problem. 2 out of 2. Nice job on this if you got these. Your questions, your numbers may be different, but these concepts are the same. Give it a try. Thanks for listening.